Welcome to the Explainer. If you've ever stared at a massive string of numbers and mathematical symbols and felt that little spike of panic about where to even begin, well, you are entirely in the right place. Okay, let's dive into this because today we're unpacking a framework that brings absolute perfect order to multi-step math problems. We are looking at a brilliantly simple acronym called GMDAS. Now, this isn't just a set of random letters. It is quite literally the ultimate order of operations rulebook. It's the system that ensures everyone, everywhere, gets the exact same answer when they look at the exact same math problem. And I want to start right here with this concept because it perfectly sets the stakes. If you don't follow the order, the math breaks. Think about that for a second. Math is essentially a universal language, right? It's built entirely on logic and structure. It's not about feelings or opinions. It's about following a definitive system. If you just decide to start calculating a multi-step problem in whatever random order you feel like, you aren't just getting a wrong answer, you are fundamentally breaking the mechanics of the math itself. The entire system just collapses. So we absolutely need a rulebook to keep the whole shebang intact.
Section 1, the priority list. Who gets in first?
I want you to imagine a multi-step math problem as an incredibly exclusive VIP club. When you walk up to the door, not everyone is allowed inside at the exact same time. The bouncer has a very strict list, and there are clearly defined levels of importance. If you want to solve the problem without breaking the math, you have to know exactly who gets to go in first. Here is that exact priority list broken down into 3 distinct tiers. This is the heart of GMDS. Step 1. At the absolute top of our list, grouping symbols. These are your parentheses. They are the ultimate VIPs of the math club. Whenever you see grouping symbols, they always go first. Nothing supersedes them. Once those VIPs are taken care of, we move to step 2, the middle priority. This tier belongs exclusively to multiplication and division. They get to go next. And finally, once all the grouping symbols, multiplication, and division are totally cleared out, we arrive at step 3, the bottom priority. This is where addition and subtraction sit. They're the very last ones allowed through the door. Section 2, the golden rule, left to right. You might be thinking about that priority list we just discussed and wondering, wait, what happens if 2 operations from the exact same tier show up at the exact same time? Now, what's really interesting about this next concept is how it serves as our tiebreaker. And the rule for that tiebreaker is brilliantly simple, left to right. Let's look closer at how this actually functions within those specific tiers. When 2 operations have the exact same priority, you don't have to guess. You just read them exactly like you're reading a book, from left to right. Take the middle tier. Multiplication and division, the M and the D in GMDAS. They are absolute equals. One is not inherently better or more important than the other. So if you see both a multiplication sign and a division sign in your problem, you simply do whichever one comes first on the left. The exact same logic applies to the bottom tier, addition and subtraction, the A and S, complete equals. If you're left with just pluses and minuses, you just scan the problem, find whichever one comes first on the left, and do that one. It removes all the guesswork. Section 3, a super simple example, 10 minus 2 times 3 plus 1. All right, theory is fantastic, but we really need to see this in practice. It's time for a live, real-world test to prove exactly how this GMDAS framework keeps our math from breaking. We're starting with this initial problem, 10 minus 2 times 3 plus 1. Now, if you didn't know the rules, if you didn't have the priority list handy, you might just look at this wall of numbers and start calculating straight across. You might casually say, okay, 10 minus 2 is 8, times 3 is 24, plus 1 is 25. But if you did that, you would have just broken the math. Let's consult the VIP list instead. We scan the problem. Are there any grouping symbols? Nope, no parentheses here, so the top VIPs are out for the night. We move down to the middle priority, multiplication and division. We have a multiplication sign right in the middle of the problem, 2 times 3. Because multiplication is middle tier, it completely beats the bottom tier operations of subtraction and addition that are sitting right next to it. It jumps ahead in line. So our very first transformation is to multiply first. 2 times 3 equals 6. Let's look at the new reality of our equation. By simply executing that one middle tier operation, the problem has immediately become way less intimidating. We're now left with 10 minus 6 plus 1. Just look at the operations we have left. A minus sign and a plus sign. Subtraction and addition. They both belong to that bottom tier priority list. We only have equals remaining. So, the crucial point is, how do we break the tie? We use the golden rule. Because minus and plus are equals, we read the problem like a book, straight from left to right. We scan from the left, and the minus sign comes up first. It's not that subtraction is somehow more important than addition, it's simply that it got in line first on the left-hand side. So we execute that operation. 10 minus 6 equals 4.
Let's move to our final stretch. Look at how beautifully simple the problem has become, just by trusting the hierarchy. We've completely stripped away all the complexity and competing priorities, and we're left with the most basic building block imaginable, 4 plus 1.
Which, of course, gives us our final mathematically unbroken answer of 5 factorial. It is incredibly satisfying when you realize that by just applying the letters GMDAS, by respecting those VIP grouping symbols, then handling the multiplication and division, and finally reading the addition and subtraction from left to right, you are guaranteed to reach the correct destination.
And this brilliantly illustrates the trap that so many people fall into, which brings me to a question I really want to leave you with today. Are you reading math purely from left to right without checking for the VIPs first? It is totally human nature to just want to read a problem like a sentence and tackle it as it comes. But as we've seen today, if you do that, the math breaks. The next time you face a multi-step problem, pause. Don't just rush in, check the door. Look for the grouping symbols, spot the multiplication and division, respect the hierarchy, and you'll find that the chaos turns into absolute clarity.